In this video, I'm going to be going over how to solve friction problems for physics. So let's say we have a 7-kilogram box and it's pushed from rest with a net force of 40 newtons across the floor with a coefficient of friction, UK, of 0.32. What is the acceleration of the box? So for this, we're going to have to draw a simple diagram and then we'll go from there. So let's diagram what we have in this situation. So notice that I put in the middle, I put a box to represent the box. Even if it's not a box, I'll make a square there. And I always put the mass inside. Okay, this is 7 kilograms. I advise always put the mass inside that so you have it centrally located. Notice we have arrows in all directions. So going straight up, the green, that's the force normal force. Opposite that, going down, is Fg, the force of gravity. To the left, I wrote F ap x, force applied in the x direction, because we're going to be going sideways. Then we have on the other side going the opposite direction, which is, so the force applied x is pushing to the right. We just do it that way, it doesn't matter. So let's say force applied x is pushing to the right. That means that what will oppose like something being pushed is always going to be friction. It's always going to be opposite. So the capital FK there in blue, the K stands for kinetic friction. Now there are kinetic and there's static, but right now I'm doing the problem when something is already moving or it's just starting moving. We're going to not do the static right now, force of kinetic friction, and that is opposite the force applied. And then we also have listed the coefficient, the mu k, that U-type shape thing, equals 0.32. So now the first thing I want to do is I want to find the force of gravity. Now notice that force of gravity, like any force, equals the mass times an acceleration. Well, in the situation of force of gravity, we have the mass times 9.8, g 9.8. And the mass is 7, so I'm going to put 7 for the mass, and then I'm going to put times 9.8. That is going to be a force of gravity, and that comes out to be about 68. So it's 68.6, we'll say. Okay, that is going to be the force of gravity pushing that box down, or pulling the box down. The next thing I want to do is find the Fn, the force normal. Okay, so now remember the force normal is the force, like let's say the box is sitting on a floor. Think of the normal force as, first you want to find out what weight does the floor feel. Okay, so that box we know is it's pressure and not pressure, but it's pushing down on the floor with 68.6, and that's in newtons. So the floor is quote unquote feeling or pushing back with or resisting with the same amount, but upward. Because if it doesn't resist with the same amount, if it can't do it, that means that the weight's going to win out and start going through the floor. Okay, and it's not going to push back up with more. The idea is that it's going to equal out. The floor pushing up will push up at the same amount of force as the weight is coming downward from the box. Okay, and then we call that the normal force. The floor is supplying the normal force. Okay, and the idea is that the net vertical force is 0, right? So we've got same amount 68.6 going down, and then we're going to have the same amount 68.6 going up, and those will cancel out because they're going in opposite directions. So sometimes they may say in your class sum of the forces in the y direction, and use that E shape, which is the sigma. So it would say sum of the forces in the y direction. Again, in this situation, they have to be 0, and technically the force of gravity, we could call that negative, but I think right now it's just easier to look at the arrows, 68.6 going down, 68.6 going up, will give us a sum of 0. Okay, and then so the normal force, as I said, has to come out to equal the force of gravity. Again, one's negative, one's positive, but just to ignore that right now, we don't need to do that in these diagrams. So the force of normal is equal to the force of gravity, so it is also 68.6, but it's upward. Okay. Now we need to find the friction force, Fk, which is there on the right side in blue. So how do you find the friction force? Well, you need to use the normal force, which we just found. And you're going to use that mu the mu k, which is the coefficient. So what does mu k, a coefficient, mean really anyway? Like, why is it 0.32? Where'd that come from? Notice when you are pushing something or anything has friction on it, a lot of it depends on what surfaces are rubbing, right? So if you have two things that are smooth, one's going across the other, it's not going to be a lot of friction. However, if pushing that box is against a rug or something that's really sticky, then that's going to have more friction. So the way that is represented in our equations is by this mu k number, this coefficient of friction. Now, there's no way you would actually know these or memorize this because it's different for every single substance. Like the floor, let's say that's 0.032 today, maybe it's a little bit moist in the air tomorrow, so maybe it's 0.35. So you never have to actually look that up or anything like that. They will give that to you. Sometimes in problems you're going to have to solve for it, but that's what the mu k means. It represents how sticky the surfaces are with each other. Okay, so then to get that, we have to do mu k times F of n, the normal force. That's the simple equation, and that's going to give us the total friction force. So in this situation, we have the 0.32 times that 68.6, because that's the normal force. That means the total normal force comes out, when you multiply those, you get, that becomes the force of friction, which is about 21.95. And again, it's to the left. So because my diagram, I can just look at it, arrow to the right, arrow to the left, and you kind of conceptually know I'm going to subtract them to get the net amount. Okay, so if you're having your equations out, you would probably call the force of kinetic friction a negative force and label it and everything, but I'm just trying to visualize it for everybody. So that's in newtons. Okay, so now we have the force applied X going to the right that the person's pushing it with, and then we've got the force kinetic friction pushing back. Notice the kinetic force friction is not as big. It's only 21.9. So, but we're going to have to subtract them to find out. So notice the force applied X to the right kind of, we'll say, wins out. It's got 40 newtons force versus the friction is only 21.9. So that means that there's going to be extra force applied in the direction to the right. And that's what I'm looking for. And that's going to be called the net force. Okay, the net force is what we really need. Now, when you were first doing force equals MA problems, you didn't talk about two opposing forces usually. You're just talking about the force. So you would write F equals MA. But now we're talking about two opposing forces. Now we're including friction. We want the net force. So the net force we'll usually write as, this again, just like we did the sum of forces in the y direction before, we can do the sum of the forces in the x direction. So they might symbolize that as sigma F of x. The sum of the forces in the x direction is the net force. Sometimes I'll just write force applied X minus force friction. That's the net force. So in our situation, what have we got? We've got, and then that, as I said, the force applied X minus the force of friction, that's going to be equal to mass times acceleration. In our situation now, what have we got for the force applied X? We ended up getting 40, and for the friction force, it was 21.9. That equals the mass times acceleration. The mass here, we use that again, is 7 times acceleration, which is what we are solving for. So when I calculate the 40 minus the 21.95, comes out to be about 18.05 net, and I'm not putting the units in, but that's newtons. That equals the 7 for the mass times the acceleration. When you divide both sides by 7, we get that the acceleration comes out to be 2.5. I'll just round to 2.58. That's the acceleration, so that's in the meters per second squared. Now that's a basic friction force problem. We're going to build on that in my next video and solve different problems where things are being pushed or pulled at an angle. But that gives you the basic idea of how these work.